Hello, I'm Andrew Grant. I'm the technical director for GAMBIT. I was also the embedded staff member on our Dearth project this past summer. The research was an artificial intelligence research question from the CSAIL lab here, which we were trying to take a Markov decision process and apply it to games. We can think of Markov decision process as sort of like a fairly very complex finite state machine, which can have, a couple 100,000 states. And that's a couple 100,000 sounds like a big number, but when you actually apply it to a game, it turns out that's not really much to play with. In particular, our product owners were really interested in the question of sidekicks, or rather a computer player that would try to help a human player. And one of the limitations they placed on us was that they wanted to have our AI sidekick try to have to figure out what the human was trying to do. So the game had a couple of constraints. One, it had to be simple enough that the AI could really get its head around the problem. And two, it had to have multiple paths to the goal. It had to have more than one way to win. Or multiple, in our case, we ended up with multiple locations. If you were trying to accomplish something, you could accomplish it on one part of the screen or another part of the screen. And the AI's job is to not only help you do it, but to figure out exactly which area you're going for. It has to be able to understand a little bit of what's going on inside your head. We're going through our initial design process trying to come up with solutions to this problem, and we had some trouble at first. A lot of our games were much too complex, and then a lot of them were very derivative, and we went around in circles. We actually spent through a number of prototypes to find one that would both please us and please our product owners, to make sure that they was going to suit their needs well. What we ended up with, it was a fairly sort of, in some sense, also a derivative-looking game, but instead of just having one player running around avoiding monsters in a little maze, we had two players running around in a maze trying to avoid the monsters and trying to get the monsters to run into each other. So in some sense, the monsters were their own worst enemies. This fit the research question very well because you had to, one, decide what kind of overall strategy you're going to pursue, sort of negotiating with your partner, and then actually enact that strategy all in real time. We did this by creating a game that had some very simple levels that you could play with the AI. As I mentioned earlier, the game problems need to be fairly simple at the moment. But we created another version at the product owner's request that basically made a two human players version. The games is then played with two players at the keyboard at the same time, so you can talk to each other because some communication is required for some of these hard puzzles. Ironically, with the AI is smart enough that you don't need to talk much. So that's one way that apparently we've succeeded. Anyway, these levels become progressively more and more complex. So complex, in fact, that the AI just can't handle them yet. And that actually is what we've provided to our product owners. We've given them a problem that they can easily solve, problems that they might be able to solve, and problems they definitely can't solve. And as they work over the next couple of years trying to improve their AI algorithm to handle bigger and bigger problems, they have a game to apply it to. If you want to check out Dearth, it's online right now on the GAMBIT website.